Alright, this video we're going to look at the instrument collection. Okay, if we look here, we can see we've got, each shelf is 15 feet long. These are 15 feet from here back to the back, and we've got 1, 2, 3, 4 layers. So that's 60 feet of instruments that we have here. And there's, in many places, they're several deep on the shelf, so it is one heck of a load of instruments. Okay, all of these are antique. They're all from 1945 and earlier. There are a few in there that are later than 1945. You know, they're more modern, but very few. There might be maybe 5 or 6 instruments that are from later times, but the majority of them are very early instruments. All right, let's take a look here. We'll start at the top here in this one, and we'll just work on back. Now, this one here is an AC voltmeter. It's a vacuum tube voltmeter and general radio, so it's absolute top quality. Got the schematic in it and everything. It's unknown as to whether it's working or not. This we'll go ahead and restore it. Okay, next we've got, these are set testers. Back in the 20s and early 30s, they had these boxes here. What they had was a connector that would plug into a tube socket. Let's say you would get it and put it in the audio tube socket, and you could measure the voltages that were on the tube by these meters, voltage and various parameters, by pushing these various buttons and things. And that would let you make measurements of the circuit without pulling the chassis out of the cabinet. Because the main thing for making money when you're checking out radios, testing radios, is to get done quick, because time is your major factor in making a profit. All right, here we have a general purpose meter. Okay, this thing has got the capable of measuring up to 350 amps. It's made for measuring battery circuits for the railroad. Look at the size of those connectors on there. Those are some butt-kicking binding posts there for 350 amps. And the voltage scale goes to 30 volts. It's made for up to 24 volts for railroad stuff, and 350 amps for measuring the current draw out of the batteries. Okay, here we have another set tester. This is basically the same as this one, but it's got one more meter, and it measures more little things like that. You just take this connector, and there's adapters that go onto the end of it that change from 4-pin to 5-pin to 6-pin tubes to where you can plug it into the radio and measure your various parameters on the tube. Okay, this one hasn't been restored yet. It's still in rough condition. Okay, here we have another one that's same basic thing. Got a bunch of these set testers. It's a different model. Has the same functions and stuff as the others. Has the different adapters. That's a strange adapter right there. It's got 4 pins on the bottom, and then you've got terminals up on the top where you can measure your voltages. Okay, and then inside there's a bunch more adapters for the different numbers of pins and stuff like that. None of these have been restored. These all have to be worked on. All right, here we have, this is a modern tube test, Sencor tube tester, Mighty Mite tube tester. This is a common 1970s type tube tester. The shortcoming of this one is it's made for tubes from about 1945 on up. It doesn't have any big pin sockets on it, so you can only measure the more modern tubes. But it's nice for any of the more modern tubes to go ahead and do a quick test on them. It's just an emission tester. Okay, now here we have a laboratory milliamp meter. This one here measures up to 1.5 amps. Well, actually it's got, no, it's only milliamps. It goes up to 1.5 amps, and made by Weston. It's no telling how accurate it is. We're going to, later on, we'll make a video on some of these meters, and we'll compare them to a precision modern multimeter, and we'll see how accurate they are compared to that. Here we have some high-powered shunts. These are for This one here is for 100 amps, and this one here is for, it's either 100 or a 250 amp. I don't know if it has it written on here. Sometimes it's written on there, but these are good for measuring very high currents. Now, this one here has got the shunt built into it. It's got one of these big, heavy shunts built into it. But if you want to just measure using your voltmeter or one of these other smaller meters, then you can use these shunts connected to the meter, and you can measure hundreds of amps. All right, here we have another. This one's a microamp meter. It's the same as this other one here, but it's for microamps. It reads up to 200 microamps. Okay. It's old. This is from back in the 40s. Okay. Now here we have more modern. This stuff here, one, two, I've got three of them. They measure various things, and they were used. They were used in projectors, and they're in here. I just put them in here. There's room for them. Heck with them. Okay. Here we have a really nice milliamp meter. It's a Weston, a high quality. And to change the range, you just have a row of terminals on the top, and you have a common, and then you pick the terminal. It gives you the range that you want. No switching or anything. By doing it with terminals, you don't have any variation in the reading due to switch contacts. All right. Here we have another circuit tester. This is the same basic scheme as the others. It's got, it measures ohms, AC volts, and DC volts, and let's see, DC current and DC current. Okay, it's a voltomillimeter, and very early Weston, from back in the early 40s probably, and it's got a set of test leads and stuff with it. Okay. Now here we have a little portable millivolt meter. So what if you have connections and stuff, like for the starter on your car, and you're trying to find where the voltage drop is? You would use a millivolt meter like this, and you'd connect the pins across the terminals, and you'd see what the voltage drop was. And if you found one that had a half a volt or so voltage drop, you'd know it had dirty connection, and you'd go ahead and clean up the connections and get that to where the millivolts indication was down in the few millivolts instead of half a volt or so. And this one's the same basic thing. It's another millivolt meter. It's used for testing in automotive work. And here we have a battery current drain meter. This was used for testing radios and things to go ahead and see what your filament current was, because your filament current. You could tell if your tubes were good by measuring the filament current. You plug the tubes in one at a time, and you see the current go up accordingly for each tube. All right, here we have a standing wave meter. This is modern. This came from about 1960 or so, and it's good up to 30 megahertz, and measures your forward and reflected power in your antenna circuit. Okay, here we have an audio voltmeter. This is used when you want to measure the power output of your audio amp. You would put a known resistor on it, and you'd measure your AC volts, your audio volts. And this one has a flat response from about 20 hertz up to about 20 kilohertz. So you can measure your power output at different frequencies and not have to worry about the meter itself being off because of frequency. Okay, here we have another little laboratory microamp meter. It's just used for measuring microamps. Okay, here is the most sensitive meter that I've got. This one is a light beam galvanometer. It has a scale that goes from 0 to 5 microamps. I mean, if you can imagine, that's 1 microamp there, 0 to 1 microamp. You can read a half a microamp. You could actually read a tenth of a microamp. 2 tenths, 3 tenths, 4 tenths, 5 tenths of a microamp, millionths of an amp. I mean, that is some sensitive meter there. Okay, and then it's good. I've checked it already. It is good. And it's got it's got a mirror that's on the coil, and that mirror takes this light bulb here and reflects the beam to give a little line on the screen here, and that moves back and forth. The mirror changes angle as the current changes and puts a line on the screen there. That's just neat as can be, but it's the most sensitive meter. I don't have anything else that you can read a half a microamp. Okay, well, I mean, you know, I've got a modern 6-digit multimeter that'll read picoamps, but you know, this one here is this is from back in the 50s. Okay, here we have just a general purpose Voltol VOM from back in the 40s, and it's got your ohms and volts and current and that sort of thing, and then capacitance. You can measure capacitance. Okay, now here we have laboratory standalone meters that are used in a laboratory. We have one here. This is AC amps up to 1 amp, DC volts up to 750 volts. Once again, you select the range by using a terminal on the front. Okay, here we have AC volts. This one's for more or less your line voltage type thing. It's got a 150 volt range and a 300 volt range. So on your 120 volt circuit, you would use this one, and it'll give you 120 volts right there in the middle of the scale. And for the 240 volts scale, you'd go 300, and that would put your 240 volts, you know, right at a good place on the scale. All right, and then here we have a millivolt meter. This one here has 20 millivolts full scale up to a 500 millivolts. Yeah, it's a half a volt full scale. Okay, it goes from 20 millivolts full scale to a half a volt full scale. And again, you pick the range with your terminal here. Okay, and then here we have an AC voltmeter. This is used when you're testing like your old radios. You want to measure the filament voltage on the tube, the AC volts. This one reads 10 volts full scale. So your 6 volt tubes would come to right around here, 6 volts, and your 7.5 volt tubes and your 10 volt tubes. Those for the filaments on the tubes. All right, now go up here. We have tube testers. These are they're not very common, but they are out there. I've got 3 of them here. The big switch here is what you set. You don't have a whole bunch of switches to set. You just have this one, and you have a chart that tells you what number you set this on. And the higher numbers are directly the tube number. So if you want to test a type 58 tube, you would take it and move it over here to type 58, and you're good to go. Plug it in the right socket, and you're good to go. It's not like a nightmare tube tester. You know, the TV2 military tube tester is famous for its huge bank of switches that you've got to set to get the darn thing set up. It takes you 5 minutes to take all those tubes switches and set them to the right voltages and stuff. But this, you just have that one switch, and that's it. Now this one's got a burned out power transformer in it, so it can't be restored without major work. It's not going to be worth bothering with. Okay, here we have the later model. This one here is about 10 years later than the first model, and the whole top from here up is exactly the same as this one. But then we go down below, and we got another bank of sockets put on here, and that covers all of the tubes that were added from about 1940 until maybe 1950. I don't know what the production date this thing is. I'd have to get the book and see if I can tell. But it has capability of measuring. Now I got another one. Here's another one over here. This is the same thing. This one is even earlier than the other one. You know, this one here is earlier than this one over here. And this one, I think, has a good power transformer in it, so it can probably be gotten working. And it's got that same switch that you just have to select the tube that you're going to do from the list, which I don't have. I don't have a list for it. I'll have to see if I can find anything. Okay. Here we have a couple of Leyden jars. This is a dual. This one's got, you can connect them either together with a wire like we are here, and we have twice the capacitance, or you can take the wire out of there and you've got separate ones that you can charge separately. and you could charge one of them positive and one of them negative for different experiments, things like that. And then this one over here is larger. This one's got twice the capacitance of this one, so it's a little bit more zap to it. Okay, then here we have a volt capacity meter. We have a standard, this is your standard voltomillimeter type situation, and you select the range by plugging into these jacks here. It has one switch that selects the function, and then the range itself you set by picking which hole you plug it into. Okay, and then over here we have the actual capacitance meter. This one will let you read capacitors. Okay, and in here you got your directions, and you got various adapters and things like that. Okay, this has not been checked out yet. We'll have to restore it and make it work. All right, come down here. We got another set analyzer. This thing here is the same basic kind of situation as the other set analyzers, and you have a switch here. You can see there's all kinds of different voltage ranges and stuff like that. It's measuring various combinations of the pins that you connect up to the radio, and I do have the instructions for it. And for tube testing, it's got the tube base chart there to where you can figure out which pins to connect to and things like that. It's not checked out yet. This will have to be restored. All right, here we have another one of the set analyzers. This is the same basic one. I think it's actually the same as one of the others over down there. Okay, this one here for sure is the same. This is the same one as the other three over down there. I've got two of those. As a matter of fact, no, this one here is a different model than that one there. This one has got a different arrangement of jacks than this one over here. It's the same basic company and all that, and the same functions and stuff, but it's a slightly different model. Okay, here we have another one. Okay, this one has got your connections that go to the tube here, and you got your meters, and then you've got selector switches that you set the function that you're going to measure. And then you have terminals here that you hook your voltmeter to, and not voltmeter, but your tube pins onto, and you can go ahead and determine what you're going to measure. All right, here we have another old voltomillimeter. This is just like your Simpson or your Triplet. It's just from an older day. This is back in the 40s. Okay, here we have another set analyzer. This one here has not been restored at all. One of the meters was totally smashed. Not politely smashed. It was actually hit so hard that the faceplate had crushed down into the meter and ruined it, so I had to throw it away. But I do have another meter that will fit in there, and so we can restore it. Okay, and here we have another tube tester. This is an old tube tester, and this is from the 1930s, and it'll go ahead and test tubes. You just push the button here to make the short test, and then you set up your filament voltage and your shunt and all that kind of crap. And this one here used the common tube pin arrangement on the tube. So anytime you plug a 4-pin tube in, it automatically hooked up the plate grid filament to the right place. 5-pin tube, same thing. 6-pin tube. So you don't have any tube pin selectors on it, like on the more modern ones. This was made early enough to where all the tubes had the common tube numbers. Okay, now here we have a very unique tester. This one, it's made for putting on the counter in a service shop so that the customer could go ahead and play with it. It had no switches. You had one switch that you set your filament voltage, and then let's see, line voltage adjustment. You just set that to 0 when you had your had it set to measure line voltage. And then this selector here, I don't know what it was. It was for, I think, the full scale range or something like that. What it did was set which one of these scales you used. And you just go ahead and look on the chart and plug your tube into the appropriate socket and have your appropriate filament voltage. And this meter up here would give you how good the tube was. If it was in the red, that means you had to buy a new tube. If it was in the green, you were okay. And if it was up at the top, well, the guy would charge you an extra $1 for that tube because it was good, extra good. All right, we'll get back, and up on the top here, we have our antique meter selection. We have just various panel meters that were used. This one here is just a milliamp meter that was used in an oxygen meter, and so it's showing oxygen percent. And then here we had one that was used in a battery-operated tester of some kind, and the green range just indicated that the battery was charged. Here we have a minutes timer, and it just you apply power to it, and it just start counting minutes and tell you how long your transmitter has been operating. And here we have a microamp meter. Now this one's pretty sensitive, but it's nothing like that light beam galvanometer. This one here, the other one is 5 milliamps full scale. Well, 5 milliamps is only half of one division on that thing. So, you couldn't measure 2.5 microamps on there if you tried. Okay, here we have a high-powered AC amp meter. Now, this one would use one of those shunts, external shunts. This one has no shunt in it. So to read the 75 amps, you connect this onto the terminals of the shunt, and then the shunt goes and measures the current itself. Now here we have an hour meter. This one here tells you how long that your transmitter or whatever that you've got has been operating. Whatever it was, this one ran for 33,350 hours. Wow. I don't know what it came out of, but it ran for a long time. And this is came out of a tube tester for something. This is an antique, came from an old set tester. That's like one of these meters here. Okay, here we have an antique amp meter. Look how that's mounted. See, the meter is on the outside of the panel. And it's not like these others that mount flush to the panel. This one mounts on the top of the panel. And the same thing with this one here. It's AC milliamps, and it mounts on the outside of the panel. There's nothing behind it except the two terminals that come out of the meter. And here we have DC milliamps. That's no different than any of these other high-quality ones, but these are made for just dedicated use. Okay, and here we have DC amps. This thing will read both directions up to 100 amps, and it has to have one of those big shunts. And it'll read out, it's like for using in a generating set where you would be reading your charge current out of your alternator. When the engine wasn't running, it would be reading negative, because it was pulling amps out of the battery. And then when the alternator was running, when the engine's running, then it would read positive, indicating it was charging. Okay, then here we have a dB meter. Came out, it was in an audio tester, and it's used to just measure the power output of a circuit, and it's in dB. This is not linear. When you go from 0.5 to 4 to 3 to 2 to 1 to 0, that's not linear. Going from 0 to 1 is very sensitive, and from 1 to 2 is like 10 times more. And then from 2 to 3 is like 100 times more than the first one. It's actually a logarithmic scale in that thing. And here we have just a voltmeter. This came from a transmitter. It reads the plate voltage, 1,000 volts full scale. You have to have an external resistor on it. Okay, DC amperes. This is another one that came from one of the set tester type thing. It's just one of the cheap meters that you put on the panel. And here we have a vacuum meter. This one here came out of a vacuum gauge, and it told the pressure that was in the system. And that's pretty much an example of all of the different types of meters that you might have. These are from the old days. We don't have that anymore. Virtually everything now is digital readouts. So these meters are no longer really made. I mean, you can still buy them. You can go to Mouser or anybody, and you can buy these meters. Simpson makes them and stuff, but People don't use them very much anymore. All right, let's go to the second row. All right, we go down here. This is a vacuum tube voltmeter, if you can imagine. Look at the size of that thing. My God, it's big. And got the scale on there, and inside of it, it's got the tube and all that stuff. And you plug it in, and it warms up, and then it has high input impedance compared to a standard old VOM. Now, this is nothing like a modern, like a voltomist or something like that. This one has, it's like 100,000 ohm input impedance. It's got a probe here. This probe has got the input circuit in it. It's got a tube in there. And that lets you measure the high impedance circuits without loading them. Okay, now in the back there, we've got a, this is a bridge. I don't know what it's used for. It's some kind of railroad stuff, and it's used for measuring very low currents, and it's whatever it is, it's there. Okay, here we have another set analyzer. This is an old one from back in the early 30s or even the 20s possibly. Let me see. No, the tube sockets are 30s, so it's in the 30s. And once again, you have very few switches. You select your ranges by plugging into these jacks on here. And the function itself, you select with a switch. You got ohms, DC volts, AC volts, and microfarads, and DC milliamps. That's what you can go ahead and measure. All right, here we have a really old tube tester. This thing is from the 30s, and it gives you a more or less emission reading of tubes, and this is as primitive as it gets. I mean, there's not even a good bad on the meter. That's one of those meters that mounts on the front panel. See, it's above the panel, but it hasn't been tested yet. We'll fix it. We'll do a video on restoring stuff like that. Okay, here we have more laboratory meters. Here we have an ohmmeter. This is a precision ohmmeter, and I don't know whether it needs an external battery or not. I'll have to check it out. I think you hook the battery onto the back here. It's got a terminal in the back, and I think you connect a battery to that, and then your resistor goes to these two terminals here. Or two terminals. Yeah, that's the button you push to make it read. Okay, and then here we have a direct current meter. It same basic scheme. It's more of Weston's precision, super duper good quality stuff, and you'd select the range by whichever terminal you're hooked to. All right, here we have a modern meter. This is an FET meter. It's like a vacuum tube voltmeter, but it's a FET meter. And this one here, unfortunately, had the batteries left in it by somebody, and the circuit board is completely eaten up. I mean, there's traces that are totally gone on the circuit board. There's not even a trace left, and about half the other traces are all green and corroded. It totally destroyed the inside of it to where it's not restorable. So it's there for, you look at it and that's all, see what it was like. But it would take, somebody would have to sit there and make a new circuit board for it and all that kind of stuff. It would be easier to find a better one on eBay and just buy the darn thing rather than go to all that trouble. Okay, here we have an interesting thing. Look at this. This is a power supply that a fellow built. The fellow that collected all of these instruments built this power supply from scratch. He used all antique parts, and except for a couple resistors there I see are modern, and a capacitor down in there that's modern. But other than that, he tried to make it old-fashioned looking as he could, and it's complete power supply for running old radios. It's got your B+ and your filament, and it's a nicely done job there. We'll keep that in the collection just to show off what you do when you want to power an antique radio, because that could be hooked to any of the old battery sets and make it work. All right, here we have, this is an interesting thing. This is a trickle charger. you would fill that jar with, I don't know what it is. It's either like baking soda and water or something like that, and that would make an electrolytic cell that would limit the current, regardless of the voltage. And you would just go ahead and hook this in series with your charger and the battery, and that would just trickle charge the battery. It would keep the current at, you know, a few milliamps to keep your battery charged up. All right. And here we have, wow. Okay, this is an old emission tester for tubes. I don't have any information on it at all, so I'll have to look it up. Oh, wait, there is. Okay. You can see it right there. Dave Rad. That is from the 20s for sure. Oops. I'm sweating a little bit here. It's almost 100 degrees up here right now. All right, here we have another old tube tester from the 20s. And this one was before 1930. The biggest socket in there is a 5-pin. So it's from the 1920s. Okay, here we have a multimeter. This is just like your Simpson 260, but it's an old military job from about 1945, 46, that area. Here we have a capacitor analyzer. Okay, if you look at some of my videos, one of my videos shows when we rebuilt this one. It's all completely in working order. Okay, here, let's see. We've got, oh, this is a watt meter. Okay, this one here, you can measure your volts and your watts. And it directly reads so that you can tell whether your radio or whatever is pulling the correct power. You know, you look on the name tag and it'll say 60 watts. And then you look on here and see if it's pulling 60 watts or not. If it's pulling 100 watts and it's supposed to be 60, you know you got leaking capacitors and stuff like that. All right, here we have another one of the precision amp meters, just like the ones we got up on the top there. And this one goes up to 300 amps. So look at that. Look at those binding posts. Oh, that means that the shunt is built into this thing. You don't need an external shunt. All right, here we have our standard 260, Simpson 260. Got two of them here. Both of them are malfunctioning. They need to be restored. All right, here we have a set tester. It has a signal generator built into it, and has a voltomillimeter on the other side. Okay, here we have some kind of a shunt box. I have no idea what it is. It's just a fancy piece of equipment. Has nothing written on it. It just, you have these plugs that plug in, and it connects these various things, and I think it's a precision resistor, and you can set it to different ohms. You can set the resistance to different ohms by plugging those connections, those plugs, into the various holes. It hasn't been restored yet. It's still dirty. All right, here we have just another voltomillimeter. It's just like a Simpson 260, but earlier. Okay, another set tester. Let's see, do we have another like that? I don't think so. This is another set tester. Here we have one of the common solar capacitor meters. These, you connect your capacitors onto it, and you can apply high voltage to it, and you can measure the capacitance of it and test the leakage of it. Look at this. This is, look at this little thing. It's a voltomillimeter. No, just a voltmeter. It's precision multimeter. Yeah, it is it's a voltomillimeter. It reads milliamps, volts, and ohms, but it doesn't have much of a range on it. The high ohms goes to 20 is times, okay, you can read up to like 2,000 ohms with it. On the low ohms, it reads up to 500 ohms. So it's, you know, it doesn't have much of a range to it, but yeah, look at that little thing. That's from back in the 40s. Okay. here's another cute one. Okay. Let's see, what does that say? It's the same thing. It's a little ohmmeter and voltmeter, and you know, it's got ohms, volts, and it doesn't have current. No, it does have current. It has current up to 500 milliamps, volts up to 500, and ohms up to, looks like 10,000. Very, very, no, up to 20,000. It says 20,000 ohms, but you're not going to measure 20,000 ohms. It's in the top eighth of an inch of the scale. So, you know, 10,000, 20,000, flip a coin. Okay, now here we have another, this is another voltomillimeter. Same basic thing as that, but it's got a little bit more functionality to it. You know, it's like a 260, but it's primitive. It's before it, a long time before it. Okay, and here we have another one. It's an older one. You know, these are just instruments to collect because, you know, they're from history and they will never ever be built again. And if somebody doesn't save them, they're going to end up in the dumpster, in the landfill, and that's the end of it. And here we have a little capacitor tester. This one hasn't been checked out yet. We'll go ahead and get that, and we'll hook it up, and we'll see if we can get it working. Here we have another one, capacitor tester, and got microfarads and all that kind of stuff. It uses I-tube. You know, these use an I-tube to go ahead and indicate the null. It's just a bridge is all it is. Okay, here we have, this is a radiation survey meter, and you know, it's used for civil defense and stuff. It was originally. Now this one here, it's like that. It's like that FET voltmeter. Somebody left the batteries in it, and the circuit board is completely green, and the lands are all peeled up and eaten up. You know, it'd have to have a whole new circuit board made to restore it. But it's not worth restoring because you can buy one of these on eBay for $75. I mean, they're just obsolete, totally obsolete. But it's good. Just we'll keep it for display. All right, let's go down. Next layer. Okay, now. All right, let's open this one, see what the hell it is. Oh, all right. This is an impedance bridge, and it's used in the telegraph type of a situation where they were measuring the impedance of telegraph lines back in the maybe even in the 20s or even earlier, and they'd hook the telegraph lines onto it, and by adjusting the switches they could null it out. It's a bridge, and they could tell the exact impedance of a telegraph line. And this is how they would tell where a short was in the telegraph line, because they would know when they put the line in. They would measure the impedance of the line, and they'd write it down on a logbook and keep that. And then later on, if they had trouble with the line, they would make measurements and they would compare the readings to the logbook. And if they didn't match, they would know which line had the short in it or the leakage. All right, here we have a nice little triplet tube tester of some kind. Don't have any data on it. We'll have to fool with it and see what it'll do. Now this is interesting here. This is a signal generator from 1930s. It has a Type 30 tube in it, and you know, it generates signal, and it works. It's in working order, and it'll go up to 20 megahertz. Okay. Now this one is a distortion analyzer. I don't know if this is in working order. This is from about 1970 or so. I don't think it's in working order. I think I plugged it in and I couldn't get it to do anything. So it'll have to be restored. But it's a distortion analyzer for measuring the distortion of an amplifier. But the problem with something like that is that the readings, you might get down to 1/10 of a percent distortion, and that's going to be it. You can't get much below that because it's a bridge, and you can only null it to a certain point, and then the leakage overwhelms the reading. So using a modern spectrum analyzer, you can tell the distortion a lot easier and a lot more accurately. Okay, here we've got another precision meter. As a matter of fact, that's the same as one up here. I'm going to just put that up here. Okay, so amperes DC. This one's milliamps. Okay, this is amps. And it reads up to 5 amps. Okay, this is a precision voltage divider. So you put 10 volts in here, and you can adjust the switches and adjust it down to 1 millivolt. Okay, or put 1 volt in here and go down to 100 microvolts or anything like that. Okay, here we have a modern AC amp meter. Here we have another one of the capacitor testers. Uses an eye tube. You can test your capacitors and break down voltage and leakage. And we have a night kit RF generator. This is from about mid-70s type situation. Okay, here we have another one. RF signal generator. Here we have another one of the this guy collected voltomillimeters until he's crazy. I mean, it's just, we've got a dozen of them. Okay, here we got another one, same thing, voltomillimeter. Here we have our classic vacuum tube voltmeter. You know, this is the real one. It's got the 1280X7 in it and the 6AL5 and the battery and all that stuff. That's the real one. You know, it drifts all over the place, but it has 10 meg ohm input impedance. Okay, here we have an odd thing. This is a tuning fork oscillator. It generates 1,000 hertz signal, perfect sine wave, very, very low distortion, because it's a tuning fork that's generating the signal. And it does not use a tube or anything to make distortion. It's done entirely mechanical, so there's no distortion. The distortion is down in the fractions of a percent, way low fractions of a percent. So if you want to like measure your audio amplifier, you can feed that into it, and any distortion that you see is coming from the amplifier, not the oscillator. And modern day distortion testers have electronic signal generators that are that accurate. But this one here was from back before they had precision oscillators. Okay, here we have a precision condenser. This one here can be varied from 100 to 1100 picofarads, and it's very precision, and it's all shielded and everything like that. So when you measure that capacitance on these terminals, that's what you've got. Whatever it reads on that dial is what you've got. Here we got another capacitance tester. All right, here we have another vacuum tube voltmeter of some kind. You know, it's from back in the 40s. And then here we have another Supreme tester. I think I've got another one right up there that we just looked at. Same exact one. And this one's handy because it has the tube data right on the switch. So there's no trouble to tell what tube goes where. Okay. Now here we have a... this is just a standard old, it's like a Simpson 260, but it's got a huge meter on it. That one there you could use like in a classroom if you're going to show a bunch of people looking over your shoulder. Okay, and then here we have another tube tester. It's an old tube tester, and I don't know if it works or not. It probably does, but who knows what the calibration of it is. Okay, here we have another one of those meters. Same basic kind of thing as the other one. As a matter of fact, it's two of them. It's two of them. This is the second one of the same exact one. Okay, so we got two of those. Okay, here's another capacitor test. Oh, no, that's a signal generator. This one here is a RF generator. And here we have an old vacuum tube voltmeter. That's a vacuum tube voltmeter from back in the 20s or early 30s. And, you know, it's got the highly insulated terminals on it, and I haven't looked at the specs on it to see what the input impedance is, but it's definitely more than the 1,000 ohms per volt or so that you had on the various tube tester. This is a tube tester. Here's a triplet tube tester, early 1920s type. It has only no, it's got bigger pins too. It's probably up into the 30s. Okay, here we have a DeForest oscilloscope. This came from the DeForest training course. The the students that took the course would build this from a kit. And we've got one. It's all tested out and working. And here we have two old oscilloscopes. These are from back in the 30s, early 30s. And they're quite rare. Occasionally you find them on eBay. This one here is United Electronics Corporation, and then this one over here is a Supreme. And this is really old. It's early 30s type of stuff. This is all restored and working, and this one's in a nice wood box. But actually, both of them are in nice wood boxes. The DeForest had a metal cabinet that went with it, but the cabinet was missing when I got it. All right, here we have another instrument from the DeForest training course. It's a signal generator. Now this one hasn't been restored yet. It's missing some parts. You know, it doesn't have much to it at all. But we'll go ahead and we'll restore it here one of these days, get it working. This is a triplet. This is one that I use all the time. I keep it up here because I use it for testing up here in the museum area. And here we have, what do we got here? Okay, this is a signal, an audio signal generator. And this one here is an RF signal generator. These are a little bit more modern. They're probably 70s, and they're in there, and that's it. All right, that is the antique instrument collection. It is one heck of a load of old instruments, and it's going to provide many, many hours of YouTube videos restoring and getting them working and showing them how they work and how accurate they were. And we will be doing those over the next year or two. All right, well, that's it.